Hello, my name is Michael, and welcome to an online edition of The Works for the Clearview Library District. The Works is for kids aged 6 to 12 who like to tinker, build, get messy, and explore. And it's a way for you to engage in science, technology, engineering, art, and math, or STEAM. So each week I'll have a new project for you to try at home. And I'll be focusing on a different part of STEAM learning every week. Now, this week we'll be working with some technology and science. We'll be doing some online simulators. So let me go ahead and share my screen and we will get started. So the first website we'll be using today is through the University of Colorado at Boulder. They have a website with a bunch of different really cool science and physics related simulations. So this is PHET, phet.colorado.edu. Now, PHET stands for Physics Education Technology. And it was founded by a Nobel Prize laureate, Carl Wyman, who wanted to improve the way that science is taught and learned. So the University of Colorado have designed these simulations, many of which will just run on the website. Some of them you have to download. So again, phet.colorado.edu. And that is Physics Education Technology. So you can click on simulations and you have different variety here. Let's just click on the first one, physics. And you see there's a bunch of little simulators here. They look like games. Let's start with something simple, balloons and static electricity. So if you're a parent or a teacher, you can click on the for teachers and you can kind of get a description of what the experiment is about. You will have to register for the site though, and it's free. So it tells us the topics for this experiment: static electricity, electrical charges, electrical force, and a description. Let's go ahead and hit play. So we see here we have a sweater with positive and negative charges, a balloon with positive and negative charges, and a wall with the same. So let's see, it looks like you can click and grab the balloon. Okay, so I dragged it over near the sweater and immediately saw that the negative charges were sort of grabbed and coalesced on this side, and they were attracted to the positive charges. And in this case, we know opposites attract, negative and positives. So I expect with that many negative charges, now the balloon will be more and more attracted the more it picks up. So it'll reach it faster and from farther away. Oh, and I see when I drag it near the wall, all those negative charges are repelling the negative charges on the wall. That's pretty cool. Looks like you can add more balloons. You can reset them, remove the wall. So that's cool. That's a simple experiment to show you how negative and positive charges react with each other. Let's go ahead and hit back and let's keep looking through some simulations here. So this is a great way to learn science that's interactive and easy to understand. Oh, this circuit construction kit looks like fun. So with this, we will learn about circuits, light bulbs, batteries, switches, all sorts of meters, capacitors, etc. Now this is one you have to download to your computer, and I already downloaded it. So let's go ahead and this is what opens. And you have these tools on the right side to create a circuit. So the first thing you need with any circuit is a power source. So we're going to drag our battery over to the workspace. And it looks like we'll probably need a couple wires, and they just kind of snap. If you click on the circles at the end, you can extend them. You can move the wires around. Okay, and what we'll want next, let's see what we have. Maybe a switch. A switch might work. So we'll drag the switch so we can turn the light off and on. We'll add another wire. And finally, let's add a light bulb. So this is going to be a really simple circuit. Okay, let's see if the switch works. Yep. So if you click on the switch and drag it down to switch it on, we see that the light turns on. Now, with any circuit, you need to know which end is the positive end and the negative end of the battery. Well, we see that the flow of electrons through this circuit goes through the negative end and is attracted to the positive end. So the electrons are flowing through. We have connections through the light bulb, the switch, and the battery. And as soon as we flip that switch up, that connection is broken and there is no light. So it looks like you can also add a voltmeter. You can turn it into a schematic so an electrician could read it. You can show the values of the connections, and then you can get into resistors and capacitors and all of that fun stuff. Then you can save your circuit or reset it. It's pretty cool. So there is a bunch of simulations on this site that are worth going through. And especially at home, if you want to keep learning, you're interested in science, it's got a lot of really cool stuff. Let's click on color vision. So this is about photons, monochromatic light, white light, and rainbows. So the description is: make a whole rainbow by mixing red, green, and blue light. Change the wavelength of a monochromatic beam or filter white light. Let's click on play and see what happens. Let's choose RGB. Oh, cool. So this is simulating the photons of light beams and how combinations of red, blue, and green are captured by the eye and what color they combine to see. So if we turn the green down and we have the red and blue middle to high, we're gonna have a purple color. So that's pretty cool. And you can actually see sort of the path into the eye and through the brain, and you can reset them. So these are just all extremely simple, fun to use little experiments to learn all about science, all about physics and electricity and biology. Awesome. So again, that's PHET. If you go to their Wikipedia site, they have a lot of cool information. Stands for Physics, Education, Technology. And you can go to their simulations and just go through, and there's a bunch of fun stuff. I think some of this will work on iPads too. Okay, and then the second website we're going to do today is called the National Mag Lab.org. If you go to National Mag, as in magnet, lab.org, this is their site. They have a bunch of information. And then if you go to education, that's where I went to find the magnet simulators. So let's go back And we have these interactive tutorials all about electronics, magnetism, tons of really interesting stuff here. And it's pretty high level stuff, but it's for younger people so they can learn the basics of this stuff. But learning these concepts, especially in science fields, is incredibly important, and this makes it very easy. So it shows different experiments that have been done over the years. Really interesting stuff, actually. So you can watch and play demos, interactive tutorials. There's a science show and tell. So I'd recommend going to the watch and play and just starting to click through and see what all this stuff does. So here's some science demos about surface tension, pressure, maglev trains. So this says 6 minutes and 30 seconds, all about magnetic levitation. And then back to the interactive tutorials. And you can click on any of these. So the arc lamp description says it was invented decades before it could be used, and it was the first type of electric light. And it was so brilliant, it was used for lighthouses and street lamps. So it sparks an electrical current between two conducting electrodes, usually carbon rods. And you can see here, there's some interactive. So it shows you exactly how they were made. They had carbon rods. And once they are close enough to attract, they create a circuit. And the electrical current will flow through the circuit using a battery or dynamo. And when the rods are pulled apart too far, the current will jump across the gap, but it has to be pretty close. And it vaporizes the carbon, and it acts like a bridge between the two rods, and it makes that light. So you separate it, and it makes the circuit separate, and it doesn't work. And then it has a really nice historical description about the invention of it. So again, just another great website that I found when you're interested in science. So again, we use today phet.colorado.edu. That's the physics, education, technology, simulation site. And then nationalmaglab.org. So the National Magnetic Lab.org. And you can go to education and then interactive tutorials. And there's a bunch of actually really good projects too if you are interested in figuring out a show and tell or some sort of science experiment. And a lot of this stuff you might not have it at home. So that's why these simulations are great to use, because you don't need to have any of that stuff physically at your house. And if you do, great, maybe you can recreate some of this stuff. But if not, these are simulations that teach you the concepts without having to have the material. And it just makes it super easy and fun to learn. So that's it for today. Thank you for joining me on the works as always, and I will see you next time.